Hello there, it's another lesson for Year 13 Maths. It's the statistics part of the Year 13 Maths course, and we're looking at exercise 16b, which is probability using two-way tables. And I reckon you probably remember these kind of two-way tables from doing them at GCSE. Certainly in Year 13 A-level Maths, Year 12, sorry, A-level Maths, we looked at them again, and they're not hard. I do remember this, having taught it before, being quite a straightforward exercise, so I'm not expecting too much problems here. And you obviously can fill in a lot of this stuff. This is the GCSE part of it, I suppose. 20 and 13 makes 33, so presumably that's 17, because they all have to add up to 50. So there's certain numbers you can work out yourself, but it might be they give you a complete full table, and then you have to work out probabilities from them. And some of them might be given probabilities. We might have to remind ourselves of that formula as well. So the data show the arrival time of a random sample of 100 letters, as well as whether they were posted first class or second class. Okay, so I immediately want to think to myself, how many does it give me? So that's 60. I make that adds up to 80. This adds up to 20. All right, that makes the 100, which they've already quoted. And that is obviously 76, and this is 24. So we've got a bit more information to get our totals. On the basis of this idea, find the probability that a letter will be delivered first class and the next day. Now, first class and the next day, you can clearly see there's 64 of them out of. And I suppose the only question mark on these questions is, what is it out of? Be careful of that. Now, this doesn't specify any restrictions on our data. It's first class and next day, so I think it's out of the total. 64 out of 100. Presumably that can simplify. So that's 32 out of 50, 16 out of 25. What's the next one? Now this is where it does restrict. This is called a given probability. What's the probability that it arrives next day given that it was posted first class? Now first class, there's only 80 of them posted. So straight away I know it's out of 80. And of course I know 64 arrived next day. So 64 out of 80. What's that? Is that 4/5? 16 goes into both of those. And the last question here says, what's the probability it's first class given that it was next day? Alright, so next day now tells me it's out of 76. There are 76 letters posted. What's the probability that it was delivered, posted first class? Well, it's 64 out of the 76. That's not quite so obvious. So 64 divided by 76. I get 16 over 19. Of course it is. So there's my 4 answers. 3 answers, can't count. So 64, yeah, I don't look at that after me working out what the simplified fractions were when I did my answers first time. I didn't bother. So all of those are fine. There's only one more example. The following table gives the data on the type of subjects chosen by students in the school. Okay, fair enough. No, this is the table we saw right at the start, isn't it? Complete the table. All right, I already know that's 17 then. That must be 18, so that add up to 38. This must be 28. So what's that give me? That gives me 68, 98. I'll make it 106. I should just check that, or I can finish the whole question before I realise I've done it wrong. So we've got 38 plus 28 plus 40. 106 is right. So presumably this must be 56. And now I can work out these numbers as well. And that's 23. And I'm just going to check here to make sure I haven't made any mistakes. 18 plus 15 plus 23 is 56. So yeah, I think I've completed the table. Find then, number 1, the probability of being, well, presumably S means science. Science, well, I suppose I should now remind you of 2 things. This set notation, this means and. Technically it is the intersection of 2 subsets. But you can see there that the N and the N, that's the way I always remember it. The alternative is it's this U shape, and this means or. The posh word is union. You can see it actually starts with U, so that helps. The union of 2 sets or subsets or whatever. So remember this. The one with an looks like an N is an and. The one that looks like a U is an or. So this is saying the probability of S and B. The probability of Notice no restrictions there, no givens. So probability of coming from S and B, so S and B, well I reckon, I'm going to do it over here because I haven't got much space. B, 1. I reckon that's S and B, I reckon 23 out of the 106 that were in this, in the table in total, because there's no restrictions. 2 says find the probability of it being someone doing science. Well, I know it's 40 out of 106. This is quite easy, isn't it? 3. What's 3 say? Probability of being a boy in this group. Well, I know there's 56. There's no restrictions. 56 boys out of 106. Now, this is the given probability. You can see them there. 4. It says probability of doing science given that I am a boy. Right? Given that the person is a boy. So how many do science? Well, obviously it's 23. Now, how many boys are there? Well, it's 56. So effectively we're restricting it just to this. That's why it's now out of 56. And the last one it wants me to calculate a probability for. Find the probability that someone is a boy given that they do science. Well, they do science tells me it's out of 40. Alright, so it's just the same idea, but now we're looking at this column. 23 do science out of the 40. Yes, out of the 40 that do science, 23 are boys. So I was on the right lines. I just got my words muddled at the end. So there's my answer. I've got to check that a bit. Which two answers tells you that S and B are not independent? Alright, I'm going to do this on the next slide. I'm going to check my answers first, and I'm going to see if I've got those right. 23 out of 106, 40 out of 106, yes. 56 out of 106, 23 out of 56, yep. 23 out of 40. I like all of those. Now, which ones? Now, I should point out that you get this kind of rule. We know that the probability, and remember it's talking about are not independent. Now, they are independent. This is what the rule says for independent. Probability of A and B, remember that technically is the probability of A and B, if I'm writing it properly, is the probability of A times the probability of B. Now if that's true, then they're independent events. Now the question says show that they're not independent. Well, I just want S and B then, so I need, let's do this, the probability of S and B, let's do proper notation, should be equal to the probability of S times the probability of B. Let's go back. What was these three things? I can't remember. S and B. Oh, please, I wrote it the right way around. That's 23 over 106. That's what I want my answer to be. Is it equal to probability of S? That was number 2. That's 40 over 106. Times by, and probability of B is 56 over 106. If this right hand side equals it, let's see what it equals. So it doesn't look as if it should. 40 over 106 times by 56 over, typed it in wrong, doesn't help, times by 56 over 106 equals, that actually equals 560 over 2809. So that is not equal to it. So this is not equal to it, therefore not independent. Now, you could easily be asked to show that they are not independent, and that's what you'd show. What's this R question actually say? Which two answers tell you that S and B are not independent? So I suppose, well, I'd say all three answers tell me they're not independent, because they're meant to equal this, and they're not. If you type that in, I've got 560 divided by 2809. That's as a decimal. That's about 0.199. Whereas this over here, 23 divided by 106, gives me 0.21. It's close, 217. But it's not the same, so therefore they're not independent. And I've said, well, either those or, well, interestingly, I've picked a different pair as well, using a given probability. So on that basis, we're going to do exercise 16b. I vaguely remember this taking about 10 minutes. Whether we do all the questions or we whip through them very quickly, we'll see how it goes. But that's it. Thank you very much.